Dear learners, now we are at 5th lecture in the last lecture of our first week agenda of managing industry 4.0. I hope you have learned from my previous lectures now. As I mentioned in my previous lecture, that is the 4th lecture, that when we talk about the industry 4.0, it involves the interplay, convergence of multiple technologies now. So, one of the technology which we have studied or we are studying is IoT world, IoT ecosystem, which is connected with multiple other technological aspects, and there are 2 or 3 aspects without which the implementation of IoT is not possible. So, in this lecture I will be discussing 2 popular technologies, cloud computing and big data and data analytics also. However, you may get some more applications, more explanations on data analytics later in my some of other lectures when I will be discussing artificial intelligence, machine learning, deep learning, how they play the role in case of industry 4.0. That time data analytics is a common technology which we will be discussing that time also. But today we will not be discussing those areas of data analytics. IoT analytics are that category of analytics which deal with the data mainly processed by IoT and edge computing devices. So, this is agenda of our this session. If you recollect in the previous lecture, we discussed about IoT architecture. Now, in this lecture, in the previous lecture, we discussed about edge computing and also little bit about data accumulation, how edge computing, data accumulation or data storage is important for edge computing. Now, in this lecture, I will be focusing again on data accumulation and to a good extent about the analytics. So, let us try to understand that. As you see this picture, again the cloud computing is sitting in between of the edge computing on one side, the other side analytic engines, analytic engines you are seeing over here, analytics engine, and which drive the action, which drive whatever analytic engine has analyzed and the output has come, it become a actionable item, like in scenario of turbine, when turbine data is being processed by analytic engine and they find that there is anomaly coming in one of the turbine, that alert is being sent to the technician and technician take the control from that point onward. So, that sort of schema is possible or is being facilitated with the help of IoT and cloud computing together. Now, what is cloud? What is cloud? So, this is a very old technology now. It is existing I will say since last more than 16-17 years, and there are different types of the cloud. So, what is internal cloud, external cloud, private cloud and public cloud? So, let us take the example. Now, suppose there is State Bank of India, and State Bank of India wants to create a private cloud private cloud. Earlier, no, they were no storing data on individual servers, no, individual servers, and there was a limitation in the individual servers because you can't use easily on a shareable basis, no, shareable basis like their data storage will be in case of individual servers will be used on individual basis, even application will be used on individual basis, but in case of a cloud, that no restrictions goes away. You can use you can have a cloud of multiple servers. Sometime we know the cloud like company like Facebook or Amazons are having the cloud of millions of servers, millions of servers. So you can build the cloud with help of many servers, many network communication links. So private cloud is basically the cloud which is being the data and the application which are being used by the company themselves. What is public cloud? Public clouds are like Amazon, AWS, like Microsoft Azure, and public clouds like Government of India's a cloud which is host our Aadhaar, NPCI cloud which host our UPI, which everybody has access to that cloud as well as they have the rights. They have the password and security to access the cloud. Cloud means the application, the software applications, and the data. So public cloud is something which is beyond the boundary of a company. So internal cloud, external cloud is like that. There is another schema. We call it hybrid cloud. Hybrid cloud means a company wants to make use of hybrid cloud. Like suppose State Bank of India wants to make use of some of the applications from Microsoft Cloud, and most of the applications are running on the private cloud, of State Bank of India. Why they like to use sometimes the applications from the public cloud? Because some of the applications are not so critical, because cloud applications, I am going to discuss that, what is the cost and subscription model in case of cloud. In case of the cloud, company need not to invest in the hardware. Company need not to invest in the software. They have to pay as they use it. They have to pay per user license or per transactions, or how much disk space they are using, how much application time they are using, how many users are there. So that is on the subscription basis. Sometimes it becomes worth for the companies to have applications which are non-mission critical, to use those applications from the outside world. That sort of mechanism when the company make use of the private cloud as well as the public cloud, it is called hybrid cloud. So hybrid cloud is a nowadays very general way of using, especially in the big companies. MSMEs kind of companies, small or medium scale companies, they don't want to, it's not worth for them to invest in the hardware and software. So they have, largely they are using, public clouds, the clouds which are being hosted by the cloud service providers. There are multiple cloud service providers. This is one area which is attracting very big investment in our country as well as. So that they use public cloud. They mostly use public cloud. So before we come and explain that how these companies are leveraging different cloud, I want to explain you the cloud services. And I like to explain you why companies wants to use the cloud services. So if you see in this picture, there are three kind of services these cloud companies are offering. Main, I will say, but there are many other services which is not part of this this session, but we will be discussing later on. One is the infrastructure services. It means that a company, what is the infrastructure? Your servers, your storage, you have some desktop, virtual desktop. Means you are not owning any desktop, but you are using desktop still using on a cloud. It's called infrastructure. So company don't want to invest in the servers, hardware or storage, and they also don't want to invest in the backups, because cloud service providers provide a very robust mechanism of the backups. They ensure that in case there is a problem in your data on the current cloud, it can be retrieved very easily from the backup systems. Then cloud service provider also provide the platform. Like suppose you like to host your e-commerce application. One option is that you buy hardware and software and then you host on their internal server. Other is that you host easily on the cloud, usually on a cloud service provider. So you like to launch a e-commerce platform, you develop your e-commerce application or e-commerce portal, and then you can easily host there. You have to pay the fees of the hosting. Then you have to pay the fees of utilizing of their infrastructure, because when you host, it will consume that infrastructure. So that fees you have to pay to the cloud service provider. And similarly, you don't want to invest in the SQL database, Oracle database, or open source database, like Hadoop or So cloud service provider is having all type of databases available for your use in a shareable manner. So you can use the databases and they charge depending upon your usage. Usage can be qualified in terms of how much disk space you have used, how many instances are being run. Similarly, there are some platforms like SAP R3, or these are very costly software, Salesforce.com. So suppose you want to use SAP R3 and you don't want to buy this software, you don't want to buy the license, you want to pay, your usage is not so heavy, you want to use only some of the applications of the SAP, you can subscribe them on the cloud, and you can customize as per your business need, and you will be required to pay based on the application slice time as well as the utilization of the cloud infrastructure as well as the software infrastructure. So this way the cloud becomes the economic way of using the infrastructure and software resources for a company, whether it's a medium or the large company. Okay, so this is I thought I will explain you the next slide, explain the different options of these services. So these services are on-premises services, means that a company wants to use their own servers, data center where applications are running, security is being provided, database are running, virtualization servers are there. Like that, companies owning their data, their infrastructure. Mostly big companies are having both on-premises data infrastructure or data centers, and then they also make use of, on need basis, the cloud services of the reputed cloud service provider. And there they have a choice, like in case of infrastructure, whether they like to subscribe applications like SAP R3, they like to also use the security softwares, like they want to run for their users endpoint software to check any anomalies in their access or any so they can use the infrastructure for the cloud service provider, security infrastructure, data security infrastructure, or web service infrastructure from the cloud service provider. So same way, in case of platform as a service, you can use applications, and software as a service also you can use applications. So this I have explained you. So this picture I have taken this picture from Wikipedia, and there you will find a lot of good explanation about what is the infrastructure as a service, platform as a service, and software as a service. So after saying this much, this picture shows that a live implementation of cloud infrastructure for some applications. So one side, like IoT, in case of IoT, IoT device will be generating some data, generating some data, collecting the data, and through a security gateway, it will be captured by cloud, where it may be stored in the data lake or databases, and then analysis will be done, and finally it will be the part of monitoring dashboard or some actionable alerts by the technicians. So this picture also gave on the same ground a perspective that how cloud architecture is being used for IoT devices and IoT data. See, I thought no, it is also good to explain data lake architecture because data lake has become very common technologies for storing the data. Earlier we used to have the RDMS, relational database management system, which is not suffice, because today when we talk about the data, you will be seeing in a few minutes, it is all kind of data. It sometimes is the scan data, it is the video files, audio files, it has different kind of social media data, and the data is coming from the devices. So data lake provide facility to capture and archive in a categorized manner all sort of data, and it is very robust technology. I am not discussing that, but one of the advantage of this data lake is that whenever data you can categorize them, you can store in a form of a taxonomy, and it create a data metadata for all this data is being covered, all this data being received, a metadata which you can use in form of data catalog and it provide data governance architecture also. So I am not going in detail this time of data lake, but it become important to be noted that data lake is a integral. Nowadays, in most of the cases, data lake has become integral part of the implementation strategy of major companies. So you should try to learn this technology also as part of the cloud computing technology. This picture shows that how the number of devices are increasing day by day. Now, as per this statistics, which has been shared in very recently by IoTanalytics.com. This is a well-known company. As per them, there is a growth of 13% year after year. Cellular data, wired data. So now, when such type of and billions of connected devices are being connected, billions of connected devices. As per one estimate, today there are more than 18.8 billion globally devices has been connected. Device means not only your computers, all sort of non-computer devices, your car, your doorbell, your phone. These are all devices are connected, and nobody knows the actual number. But as per one estimate, it is more than 18.8 till last. It is about last year December month, 18.8. And this is the speed it is increasing. So to deal with this, you need a very different kind of mechanism. So big data come into picture, and beyond big data now we are seeing different technologies has come. Public data lake is there, data fabric is there. So it is better. It is quite important to understand what is this data, what kind of data is there, and how IoT is connected with this data. So this picture shows that kind of data, business data is the transaction data, email, and these are the human data generated. Emails are being generated by humans, videos and images are generated by humans, social media data, and then IoT sensors data. IoT is and sensor data is coming, so it's called machine data. And if you try to categorize them, it is being said that structured data is very small part. Structured data which we find on our database is very small. Most of the data is unstructured in form of images, videos, audios, or social media data. These are unstructured data. Structured data is the data like sales data, your transaction data, your inventory data. So these are the structured data. So the structured data part is very less as compared to unstructured data. This picture again shows. So what do you mean by big data? So big data is comprised of all sort of structure, semi-structure, quasi-structure, unstructured data. So here this slide give a categorization. What is the structured data which you find in your Oracle database? What is semi-structured data which you find in your data like data lake or Hadoop? Then quasi-structured data is again data which is not structured or not only semi-structured. And what is unstructured data? I explained you a few seconds before that the data lake, data lake and data fabric are the platform which provide the storage of unstructured data, all sort of data, whether it is a structured data, semi-structured data, the unstructured data is a very important data. So these are the type of data This slide shows 5 V's. That is also one of the important technology, important terminology, 5 V's of big data. The point is that if there is a system which is going to deal with the big data, it has capability to deal with these 5 V's. What are the 5 V's? Scale of data. Data is increasing day by day. It is being said every year data is being multiplied by a factor of 2 or not 2 by 4 data. Volume of the data is increasing so high. Analysis of streaming data, the speed of data with which it is being transmitted on the network. So your server should be able to capture with that speed. If the server is not able to capture or your system is not able to capture with that speed, then data will be lost. Similarly, different form of data. Your server variety means your server should be able to deal with all, your software should be able to deal, big data services should be able to deal with all sort of data. And then how much value you are generating, what value you are generating for your customers, for your company, that is also part of the big data analytics. And then uncertainty of data. It means that if there is discrepancy in the data, you should be able to identify the discrepancy. So all these 5 areas, 5 characteristics become the part of the big data. If any software you say is a big data software, big data analytics software, it has to deal with all these volume, velocity, variety, value and veracity. I have again given in this picture a categorization of the different type of data, and you can go through this picture, textual, with examples. It has been given over here, like numerical data is what, image is what, and audio is what, just to take a complacency. Now, what kind of data analytics are there? So basically, we study these 4 kind of analytics: descriptive analytics, diagnostic analytics, predictive analytics and prescriptive analytics. What is descriptive analytics? Normally, most of the MIS system, management information systems, are descriptive analytics. They give a view about what your business has done. What has business has done yesterday, or last 1 week, or last 1 month, or last quarter, or last 1 year, like that. What has happened? Diagnostic analytics talk about what did happen, why did happen, what was the reason for this kind of sales going down, why this sales has gone down in this region. So that is called diagnostic analytics. Why this equipment has gone down, whether you have taken care of this alert in the last alert. So what was the reason? Diagnostic analytics. Then predictive analytics, what will happen, which will predict that this is likely to happen. That is called predictive analytics. We will see that little more detail. Then prescriptive analytics. Then here the system prescribe that you should take this action so that this problem should not occur, or you should take this action to double your sale. It's called prescriptive analytics based on the data. So data play a very vital role in all these type of analytics which we will be seeing one by one. This picture again shows some of the examples of these analytics, descriptive analytics, what has happened, monthly sales reports showing revenue trends and over the past year, and the diagnostic, why did it happen? It shows that root cause analysis of sales dropped. What was the root cause analysis of sales which has dropped? Identifying the factors like computer promotion, some companies have, and supply chain issues. Supply chain issues sometimes become the very important issue. And predictive analytics, what did happen? Why did happen? Why did happen? And you are going to it is printed wrongly here. Predictive analytics will say what can happen. What can happen? What predictive analytics is predicting that. So forecasting the next quarter sales using the historical data. You make use of the historical data. But in case of prescriptive analytics, it makes use of that your real-time data, optimizing inventory level to minimize cost based on demand and forecast. So there is a silver line between the predictive analytics and the prescriptive analytics, which we have to use. Why this is important? In most of the companies today, there is a focus on predictive analytics, and as per the market survey, companies who have implemented predictive analytics, whether in the manufacturing or whether in their business or marketing or inventory control, they are able to get the very good return on the technology. I have explained in this slide all these 4 kind of analytics, descriptive, predictive and prescriptive analytics. You can go through. Basically, important area which has to be understand is that for development of descriptive analytics, what kind of common techniques are being used. Common techniques are data aggregation, visualization, dashboard kind of thing, KPI, key performance indicator. Because if you have the key performance indicator, you will be able to understand that that what is like key performance indicator of your sales. You have made a target of 20% sales increase in a year's 12 months time, but it has shown only 10%. So KPI is a very important thing. Trend analysis in the market, that is, these are kind of technologies or these kind of tools you should use for using the descriptive analytics. Coming to the predictive analytics, tools like regression, analysis of statistical mathematics, decision trees. These are again a tool of the statistical mathematics. Machine learning. Machine learning is also commonly used now in case of predictive analytics. So neural networks. This is also very important aspect, clustering. So if somebody wants to develop the predictive analytics, you should learn these kind of technologies, technologies or tools around these technologies. And you have to learn. So this is also very important area for our industry 4.0 predictive analytics. And if you like to implement industry 4.0, you should identify the areas where you can apply the predictive analytics in your company. Prescriptive analytics make use of the advanced technologies like optimization, simulations, scenario analysis, decision tree. So here again is quite a bit use of the technologies. Without technology, you can't do prescriptive analytics. So I will say that this subject, prescriptive, descriptive, diagnostic, predictive and prescriptive analytics is an important part of industry 4.0 technologies. If you want to gain the benefit of the industry 4.0 technology, these are the worth studying the technologies. There are few examples I have included in this deck. How the Amazon is using predictive analytics to offer anticipatory shipping. Because they by leveraging predictive analytics tools alongside Amazon vast customer data, anticipatory shipping process will be in state of readiness. So they use the predictive analytics that order or booking of this kind of products will happen in next 1 month in what kind of quantity. So depending upon that, how the product is being sold out on the platform, they will predict that so and so product is likely to be sold in so many numbers, and they accordingly they will try to keep that quantity in their warehouses. That is a part of their fulfillment scheme. Similarly, Netflix also predict use left and right predictive analytics for different applications, like by leveraging vast amount of data such as viewing pattern, search histories and user ratings. They can identify trends and preferences among their audience. So what kind of films or audios their audience or their customers are liking, depending upon they can decide the strategy for next videos, and so that they can satisfy one side the customers and they can generate more business. So predictive analytics is the part of most of the organizations. This slide give a detail or a list of the technologies and the tools which we require to develop these kind of technologies, descriptive, predictive and prescriptive analytics. I am not going in detail, but when you want to study all these analytics, you should also try to study all these technologies. In the due course of time, some of these technologies I will be discussing in my lectures. This is a list given. I have created what kind of analytics, what kind of applications of the predictive analytics there in the business applications. Now coming back to the last leg of this lecture, what is the use of IoT? Defining IoT analytics. IoT analytics refers to collecting. So this we have already discussed about the IoT. IoT is basically the technology which is being used for analyzing the data which is being captured by the IoT. This slide is very important. One side you can see how to build this application IoT analytics, connect devices, gather data and process. How to get benefit? Predictive analytics. So using this data, you can do all those three kinds of analytics which we discussed now. This shows again a typical implementation of predictive maintenance applications. One side you have the pump, vibrating pump, which is and the IoT device is capturing the temperature, vibration and temperature, and it is being transmitted to the cloud, which is processing is being done. And if there is any malfunctioning happening, it will generate an alert, and the technician will take control on that. So this is a very important area which most of the manufacturing plants or manufacturing companies are implementing now, and worth looking. So here again I have shared a list of use cases in case of manufacturing, transportation, logistics, smart cities, healthcare, agriculture. All these use cases are well tested in the industry, like predictive maintenance, asset utilization. Everywhere now you can use all these use cases. In all these use cases, we can use data analytics and predictive analytics, prescriptive analytics, diagnostic analytics, and descriptive analytics now. So if you see a common chart or a common application of IoT in manufacturing, this picture shows in a nutshell how the IoT is improving the performance of the machine if you are able to capture the downtime beforehand. Similarly, how IoT analytics are helping the energy companies to or energy savings in company, when you can make use of the IoT for power. You can have some tracking mechanism that in which time of the day there is a peak consumption of energy, and so that you can take some action on that. Similarly, IoT analytics can be used for quality monitoring in form of defect rating identification and deviations, and also IoT can be used for equipment health, by measuring the temperature and vibrations. So IoT analytics is a quite generic requirement in the industry, and fortunately today we have a very quite mature technology, lot of tools available. Companies like Siemens, Honeywell, in case of manufacturing in the process industry, they provide lot of good tools in this domain. I like to end my lecture showing this picture of that how IoT is being used in retail and manufacturing plant and connected car, smart cities and homes. Especially in case of home, we have smart homes concept, where every facility in home, like electricity equipments, our kitchen equipments like refrigerator or our other equipments in the kitchen, stoves, etc. They all are connected with the sensors, and we are able to manage. Manage the consumption. If any there fault inside. So it is becoming the Google Homes is a very good industry application. Anyone who want to know that how the smart homes are being made with the help of IoT technologies and Industry 4.0 technologies, Google Home provide a very good industry case studies. So thanks. I hope that if I like to summarize this lecture, we have learned in this lecture three aspects. One is that how the cloud computing is useful, what is cloud computing, and how the analytics, big data, and what is the formation of big data, what is the idea behind the big data, and then how to make use of big data with the help of data analytics, and which are the kind of data analytics tools available in the market. Thank you very much.